Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. Now, let's look at question 5 under May June 2022 question paper. Okay. Now, it is work, energy, and power. Okay. Topic. It says arrestor beds are used to help moving trucks to come to a stop when their brakes fails. Okay. Good. Good. We need these arrestor beds. The driver of a 30-kilogram truck driving down a steep road drives onto an ascending means from lowest to highest, right? Ascending arrestor bed from which is 28 degrees to the horizontal. Here it is that arrestor bed, right? This is okay. I'm now telling you for future purposes, this is a very good arrestor bed that is ascending for trucks or cars that do not have brakes. Why? Because as it moves upwards, the friction will oppose the motion as well as FG parallel. Okay, so there will be a net force acting downwards, opposing the changing X there. Okay, but if we have an arrestor bed that is like this, okay, it's gonna be difficult now because why? An object or rather a truck is trying to slow down, but there is a FG that is moving it downwards, and the friction will act alone in that opposing side. Okay, so it is better to have an ascending arrestor bed than a descending arrestor bed. All right. Now, 5.1 says now state work energy theorem in words. Now, I remember it is W net it is equal to change in K. So wording it is very important. The words comes from this formula. You say now the network done, can you see the net work done in moving an object is equal to the what? To the change in kinetic of the object. I repeat, the net work done in moving an object, it is equal to the change in K of of the object. I move on. The truck with failed brakes passes point A at the beginning of the arrestor bed at a speed of 33.33 meters per second. Okay. The average frictional force of the truck is 31 Newton, while the truck moves up the arrestor bed. Okay, I'm not making sense of the statement as of yet. I'm just reading. It's fine. Let me repeat that. The truck with failed brakes at point A, okay, at the beginning of the arrestor bed at the speed. Okay, the truck with failed brakes passes point A. Oh, passes point A at the beginning of arrestor bed A at a speed of 33 33 meters per second. Okay, when you read, please make sure you make sense of your statement because it's very important. So we'll start from at A. Now it is moving with a speed of 33 meters per second, right? Now we are told that the average frictional force of the truck it is 31,000 newtons while the truck moves up the arrestor bed. So now as it moves up the arrestor bed, my truck they're off. I don't know how to draw. I don't know how to draw. And I don't care. So we are told that we have a frictional force of 31 newtons opposing the remember frictional force opposes the motion, right? So now yes, ignore the rotational effects of the wheels. Okay. Now the question says to us, give a reason why the network done on the track while moving on the arrestor bed is negative. Now it's because now it will come to rest here. Okay. Remember here, a final velocity, it will be 0 meters per second. You can say now, can you see now the change in kinetic energy? The change in kinetic energy will be kinetic final minus kinetic initial. But what is kinetic final? Kinetic final, it is 0. Since it is its velocity is 0, right? So it means now our change in K, it will be negative. Can you see that? So yes, the answer that you can use for reasoning here, give a reason why the network done uh, while moving on the arrestor bed is negative. You can say now our change in K is negative. Can you see that? change in K is negative. Or one might say now the net force is opposing the motion. What do we mean the net force is opposing the motion? Remember, if I'm having my drag here, the force is acting on it. Let me draw a free body diagram. I have broken it. I'll break it into its components, okay? So this will be my, okay, fine. I'll have friction. I will have FG perpendicular. Here, going downwards, I will have FG parallel. Let me try to, like this. My normal, this is what will, there is nothing, no force in that direction, no force, okay? So can you see that my net force is opposing the motion, okay? Is acting in an opposite direction to the displacement. You can say F net opposes motion of the displacement, okay? Of the displacement. Okay, yes, these are your two reasoning thereof. Now let's move on. Now it says to us now 5.3, use energy principles to calculate the minimum length. Okay, the minimum length, that is what? That is required to bring this one, to bring the arrestor bed, or sorry, to bring the drag to stop. Okay, so now we want the minimum length that this drag will travel to reach the to reach stop, okay, or reach the final velocity of zero thereof. So what am I going to do? I'm going to apply W net. What I like to say is that what the examiner wants you to state here is what you're going to use, okay? So let's use W net, in this case the off. You're going to say now W net, it is equal to change in K. I want you to realize that our free body diagram was something of like this. Friction, let me do this. We had friction. We also had mg sine theta, which is FG parallel again. But remember, we are interested in the forces that are doing work. Remember, forces that are doing work are the parallel forces, right? Forces that are acting parallel. In this case, the of. Yo, I've drawn this so bad. It was supposed to be like this. But yeah, the forces that are doing work are the parallel forces. Okay, so friction and mg sine. But can you see now they are opposing my change in x? They are opposing my change in x. So it means the angle that I will use here, it is 180 for the both of them. I believe you are following. Sorry, where's my water? All right. Now, what are the forces that are doing work? It is friction and mg sine theta. Okay. All right. Water is very important. So, do you all agree with me? It's going to be work done by frictional force plus work done by FG parallel. Okay. It is equal to now, what is change in K? Remember, change in K, it is a half mv squared final minus half mv squared what? Initial thereof. Okay. Now, but now I want you to take note of something. My final velocity, it is zero. It is zero. Why? Because it will come to rest. So it means this one will fall off to zero. I believe you are following. So this one will fall off to zero, and I'll have something like, yeah. When it follows, you can also substitute and do your math. It's fine. Here it's gonna be f changing x cosine of my angle plus, or even instead of doing that, it's fine. I'll say this is mg sine theta. This is just the force. Okay, then multiply by changing x cosine of theta. Actually, let me use a different angle here. Let me just, it's fine. It's just theta. It's fine. All right. It is equal to, now I'll factor this one out, half m. Okay. Then I'll say it is vf squared minus vi squared, because they both have half m. Okay. Now let's substitute. What was our frictional force? Our frictional force was something like a 31,000. 31,000. Okay. Now I'm looking for my change in x. Cosine, remember, of 180 degrees again. Plus my mass thereof, my mass was 30,000. Then my gravitational acceleration is 9.8. Sine of the angle between the arrestor bed and the horizontality is 28 degrees. Then my change in x, it is what I'm looking for. Cosine of 180 also. Okay. Then I have half. What is my mass? It is 30,000. Then final velocity, it is 0 squared minus 33 squared. 33 squared. Okay. Okay. Now I'm in a position of now punching everything into a calculator, but it's fine for the purpose of others that are still struggling with this, how to punch this on a calculator. Just say, okay, this one 31 multiplied by cosine 180, it will be negative 31,000. Okay. Now 30,000 multiplied by 9.8 multiplied by sine 28 degrees multiplied by cosine of 180. Sorry, cosine of 180. It will be negative. Let me punch that. 30,000 multiplied by 9.8 sine of 28 degrees. It will give me something of minus 1380. Yes, 1380 24, comma 6395, change in x. Okay. Now when I punch this on my calculator, 0.5 multiply by 30,000, then multiply by 0 minus 33 squared. How much do I get there? I get something negative 163,350,000. Okay. Then here you'll see, man, you know how to do your math. I just wanted to show you how you can move about that one. You'll get an answer of 96.64 meters. Okay. Now, how do they mark this? Very important. For either of these, this is just you manipulating 1 mark. Then for the substitution of 31,000 and cos 180, 1 mark. For the substitution of your mg, okay, mg sign, another mark. Your right hand side, another mark. Then for your final answer, this is just mathematics. We are not teaching you mathematics, we are teaching you physics here. Okay. Remember, physics is just for now. Now that you haven't done dimensional analysis, you just formula substitution and answer. When you reach university, you'll use a dimensional analysis. You do not substitute until you have reached, like, you have to manipulate a formula first before you substitute. You have to make change in x the subject of your formula first, then with other variables, then you'll be in a position of substituting. But now this is interesting, grade 12, nice stuff. I just formula substitution and answer. The examiner is happy. Right. Last question. Now we are told that the diagram below shows this same track entering a descending arrestor bed inclined 28 degrees. Ganjalo, the initial speed of the track and the average frictional force of the track are still those ones. Okay, they remain unchanged. Now, which arrestor bed, ascending or descending, will be able to stop the track in shorter distance? Remember, when we entered this video, the first thing that I explained, it was with regards to the arrestor bed. I said it is very beneficial to use an ascending arrestor bed than the decreasing. Why? Let's check. Already the answer is ascending. Okay. Now let's look at the reasoning. Check here the forces acting on. Let's see the forces acting on the track. Can you see that we have FG parallel acting downwards? and now Fg, sorry, friction opposing the motion. And now can you see that this part Fg parallel, it is greater than friction and it is still making it to go down instead of making it to stop. So we'll say F net for the descending one, it is equal to what? Fg okay, Fg parallel minus friction. Okay, it is Fg parallel minus what? Minus friction. Now, for the ascending one, we saw that the net force acting there, the net force acting there was two forces. It was friction as well as what? Fg Fg parallel. So now can you see that the net force here, it is opposing the motion. The net force here, it is equal to what? Let's do that. The net force for B, let me say net force for the ascending, it is what? It is Fg parallel plus friction. Yes, I know they are opposing the motion, but for now, I'm just concerned with the direction in which they are moving. They are moving in the same direction, so hence I'm adding them. Now, can you see now that the F net for the arrestor bed is greater than the F net? Sorry, the F net for the ascending, it is greater than the F net for the descending. Yes, because here Fg is greater than F, so it will cause it to go down. But in this case, Fg and F are working together to make it stop. Okay, take note that changing X, it is in that direction. Take note that changing X, it is in that direction. So now when I dispute my answers, I'll say for this one, it is that. Okay, then for this one, okay, it's fine. For this one, it is this. Okay, sorry. Okay, but now can you see now that the net force acting now on an object, it is now where is my F net? Okay, it's fine. Okay, now this is your explanation. The net force acting on the ascending one, it is greater and they opposing the motion. Okay, so for this one you'll just get a mark, then for this one a mark. Or you can say now the F net for the ascending or act in the opposite direction of the motion. I get. Or you can say for the ascending, Fg parallel oppose. I get motion. But for the descending, Fg parallel, it is in the direction. I get supports the motion. So in this case, can you see now the conclusion is that now a net force for descending arrestor bed will be smaller, or you can say net force for ascending as English is gone. Ascending is greater than the net force, but this is the same thing that I've been writing here. Okay, so yes, that's the analogy of that you can use. Okay, or you can even use your own words, but make sure that they are nicer. Okay, yes, they are nicer. They're off. All right. So now let's meet on question 6 under this very same question paper. Okay, I hope you understood the concept. Thank you.